all yours, Professor.
Make sure it's well balanced. I don't want to be responsible for falling over.
Right. There we go. I can see your screen.
Ooh, this isn't my screen.
Oh.
I'm sharing. So you gotta make sure you're doing what I'm sharing.
There we go. Boom, boom.
Good.
There we go.
All right.
Perfecto.
So when you do a 3D view, of course, as you probably know by now, I can go to duplicate view. I can duplicate with detailing. And if I have other things like walls and stuff that I want to hide, I'm able to just go to hide and view by category. And if I do that with enough stuff, eventually I'm just left with my superstructure, right?
Yeah.
Right?
Yes.
I could have answered that question.
Well, I sort of. You remember I told you
No, I don't. Repeat.
how I said that I did mine on a regular floor plan, so I did sort of do that.
You did sort of do it. What's that mean?
But I ended up having to just highlight my whole project and just hide it all and just unhide just the specific columns.
And you see, I should be able to pretty quickly start to see what my building framing is going to look like. So if I'm doing this on a mass scale for the entire structure, that's what it should look like. Okay. If you have a 3-story building, of course, your framing would be a little bit more interesting to look at than mine. But it starts to paint a picture pretty fast. So back to the point about annotation, though. If I go to annotate and I go to category, tag by category, I'm able to hover over something and it says no tag for structural columns. I like to add one now. Well, that's interesting. So I don't know why that would be. Let's see. Tag by category. So for some reason it lets me tag the beams with relative ease. It's not going to let me do this for structural columns. So let's see if I can use my technology to do a tag for structural columns. Yeah. And bam. Now you don't have to do leaders. Just like before, if I tag by category on my top ribbon here, I can do no leader and I can just hover over it and then I can just move it over. It's not uncommon to see this. When you add more lines on a structural diagram, it gets kind of confusing. So sometimes you would rather not have a leader on it. For something like a column, if I wanted to do it post, I would just go to leader and untoggle it. And voila. Now I'm starting to get a sense of what I'm building. Putting it in my model and now tagging it. Capiche? One of the bonus round things I wanted to talk to you about was if I go to like an elevation. Let's go to. So again, if you ever see an elevation, it looks like this. Like, why is all of a sudden my model a bunch of stick built stuff? You go to fine, and all of a sudden now it looks like a real set of columns. Because in the structural model, medium and fine are more detailed than just that. So if I'm in coarse view, it's just one line. If it's in this view, you can see multiple of it. So now the question is, how do I show like how I would detail these things? If I really zoom in, you'll see like this intersection here. So I'm just kind of blowing through it. And the reality is that isn't really what would probably happen. I'd have to probably have 2 that are welded together, or I stop the column short or whatever. So we talked about this very briefly, but just to recap it, if I go to this item, you'll see that I actually have the ability to cope. So cope is a term we use, and you'll see here it says, coping applies steel beams and columns at new locations where beams fit into girders. So if I do something like that, it starts to automatically make those cuts for you. So in theory, when you do coping, if I were to select the beam or the column, hit cope, it's going to say select item to be coped, which I'd select the column, and then it says select the item that you're going to use to make the reference. So I did it twice because I did two different ways. But if I click this guy, cope it, now you'll see the way they cope it, it's kind of hard to identify that it's been coped. But once I do this, you can see the ghost line. Yeah. Okay. Now this isn't a very conventional way to do it. What would probably happen in reality, if you were going to do that, is you would just state an offset on the top of the column that's similar to the depth of the beam. Now the question I have for you is, if I select this beam, how do I know how deep the beam is? I don't expect Carlos to know because he wasn't here, but we did talk about this.
It's on the thing. I can't read it. That's W.
So W12, what's that mean?
It's a width of 12.
So it's a depth of 12 from flange to flange nominally, meaning that if I were to offset this guy by a top offset of negative 12, whoops, it went up, negative 12, it will crop it to approximately where it needs to be. So if that's how I was going to detail it, that's what it would be. Probably more reasonably, what would happen is the beam itself would be the one being coped. So instead, what you would do is you go back to the coping, you pick this guy, and you're going to cope with that. And voila, it will automatically cut it. And then it makes it two separate beams. Okay? And that's practically what would happen, most likely. But that's going to depend on your structural engineer. Because then you have more stuff to tie into, making it a more robust connection. Does that make sense? So of course, then the question is, if I wanted to show detailing of how I would kind of tie these things together, or how I would do any structural details, typically that's not going to be done on your model. You would do a blow up view of that. And as I was trying to start to say, if I had a view on the south side, I show it as a fine connection. I could zoom in to where this connection happens, and I can do a view, call out, and then if I click it, it goes back to that level of refinement again. So I should go back to make it a fine. And the question is, how do these things get fit together? So in this instance, it's going to be kind of hard to see because the flange is facing me. But, every now and again, you'll have these details where columns are meeting girders or something to that effect. So I want to talk about that kind of typical detail really quick. So what most likely would happen is that these columns get interfered with a fat beam, also known as a girder, a deeper member. So if I go to the beam, I go to properties. Right now I just have W12 in here, but we'll just keep it like that for a minute. And it says I can't really see it. So I go back to 3D to see what was going on. And you'll see it kind of put it in some random place here. So I'd want to go back to my properties and see why it's sticking to that level. Well, it's for some reason on level 1. I probably want to put it on the roof. So if I go to edit work plane, this is an important workaround. Carlos, who talked about it extensively. Go to pick a plane, and I can put it where I want, which is level 2. And that's where it goes. So now you're starting to see it looks like a complicated sandwich of a bunch of different things. And in practical, like I said, reality, what would happen was this would be like a -1. And you'll see it's associated now with the top of that, this beam. So I'm still not in my right area. So I go back to edit work plane, and I can actually go to the top option, which was pick new. Sorry. I go to the top option to edit work plane, and it says edit work plane. And on this menu, it makes it a lot easier because you can just pick a plane, or I can pick a line or whatever. So in this particular instance, you want to pick level roof on the name of the work plane, and it will just put it exactly where you want it to go. So then the question is, if I'm going to cope, I have to figure out what I want to cope. And typically the right of way goes to the more important load bearing structure, which would be the girder. So I'd want to cope against the girder. So if I go back to coping, it says select what is going to be coped, which would be this guy, and what's going to do the coping. And now you're starting to see an actual, this is probably how it would get done. You'll see it kind of notches out, keeps it nice and flush on the top. Why is that important to keep it flush on the top, you think? Yeah. I mean, I'm ultimately trying to build a building, right? So an architect is just thinking about, I have a floor. Typically the flooring will be a topping of concrete, which is shown with Doritos and dots, just so you remember. And typically that is going to be poured into a corrugated metal deck. And then that would really infill that decking. So then the question is, how is that going to tie in? Typically what's happening is I have my beams, and every so often those beams are going to support that decking, right? So if I have my girders like up a certain height and my beams at this height, what do you think is going to happen? It's going to be a mess. You want everything to be flush on the bottom of the corrugation so it has a level of support. Does that make sense? So imagine I'm building this building, Carlos, and the contractor's like, okay, so the girder, top of the girder is here, top of the beam is here. Well, if I have a beam, if I have a diagram that's like this, and the whole point was to get as many points on the grid that are level with each other to lay something on top of, if these two are at separate heights, and I'm putting something like a corrugated deck down, I'm only able to use either the horizontal or the vertical to attach to, because they're not at the same height. I'd want both these guys to be at the same plane in order for that to work. So my girder would want to be here at the same level as the top of the beams. Does that make sense? But then the problem is, as I just got done talking about, how do I attach it? So in this particular instance, it's kind of not showing it accurately because my girder and my beam are the same depth. So it's kind of unrealistic that you would have your I-beam look like this, and then you're just going to notch out the entire thing for your other beam. What's probably going to end up happening is something more like this. Your beam is a little less deep, so that part doesn't get cut. And because I want to be as accurate as possible, why don't I just go ahead and see if I can pin this down for us. So if I go to component, let's go to insert. Go to insert, load family. I'm in structural, but these are all annotations, so I gotta go way back. So go to structural. Framing. Let's go to steel. And you see you have wide flange. I press open. And all of a sudden now, it's got all these different sizes. So if I go OK, it's going to upload it in. Hopefully if I click it, now when I go down, sure enough, it's not in here. Let's see if I can figure out where to get it. Usually when you do that, it would just load them in here, but they're not in here, which is kind of frustrating. So for the sake of just showing it, in case it doesn't work for you too, you can always go to duplicate, and you can make another column shape. In this case, I'll make it 8 inches deep. Now, of course, the issue with doing this is that you're kind of guessing like what all these things are when you really shouldn't be doing that. But for the sake of this demonstration, if I were to make this, say, 8 inches for supply, you'll see that's what happens. The benefit of doing the coping is that it automatically knows where to cut. So you'll see what was cut down here is now flush. So what's happening? Well, because my beam is not as deep as my girder, I only notch out the top part there. You following? Okay. So then the question is, let's say I was trying to show, as a structural engineer, my details. If I were to go to view, let's go to,
You changed the height, right?
I changed the height. If I go to roof framing, you'll see this is where I'm at here. I could do a section cut. Whoops. I can do a section cut. And if I go back to my coarse view and make it a fine view, here we are. We're starting to see this detail up close and personal. I can actually go ahead and just focus on this one part. But this is important because if I were to say want to show how I'm detailing all of this, this is a view that's of critical importance because I have my beam, my column, I have my girder, and I have my beam. So in this particular view, I have a few ways to go about continuing to add detail. One of the things I'm interested in, though, based on what I just said, is structural tab has the ability to add a floor. So you'll see here it says floor structural, floor architectural, floor slab edge. If I do floor structural, it's going to ask me to pick a level. Take floor framing. The key here is what kind of floor am I pouring? You'll see here it says WL concrete on metal deck. Well, that's the one I want. Okay? So whether it's a 3-inch or a just lightweight on metal deck, the one that looks like a corrugated one in the model would be the 3LW concrete, which is lightweight concrete on a 2-inch metal deck. So if I click that guy and I just treat it like I'm doing this for my normal floor, I take the whole structure and I press OK. I go back to that section I just took, and in theory, it should look something like that. The level of detail is showing that it's cut the other way. So in this particular model, I'm not seeing it the way I'd probably like to be seeing it. But that's because if I go back to the framing and I double click, remember this guy? We talked about this before with the decking. Right now, the direction of the span direction's that way. So if I click this direction and I make the span that way, if I go back to my call out, now I see the corrugated. So typically what happens in an architectural model is you like to specify the FF, the finished floor height. Okay?
Was our project supposed to have
No.
a
I'm covering new material.
oh, okay. Because I had to implement a beam system.
You didn't do a beam system?
Yeah.
Well, we're not doing a beam system necessarily.
Why?
Huh?
Why? Okay.
So, just for the sake of argument, because everything is sort of set off the FF, what I'd probably want to do is offset these numbers a certain amount to reflect what the depth of the floor is. So, of course, it put it up by 5 inches. So I'd want to do -5. it's not doing negative, so I'd have to do negative at the front and then negative at the end. And you'll see now it's in line with the bottom of the corrugated. Similarly, I want to offset my column. -5, whoops, to -5. Now it looks like I lost my coping though. My coping detail. So the question is, how do I get that back? Well, again, go to coping. Where am I coping? This guy. What am I coping against? This guy. I guess I moved the section. I don't know why it's not showing up. There you go. So this guy still has to move down. So again, offset by 5. It needs to be -5. And again, I'm picking 5 because that's the depth of the system that we picked for the flooring. And for some reason, this didn't remember what I did. So this has to go down by 5. So I'm not down by 5 more inches. And then everything should be pretty much aligned. So why all this trouble? Well, how are these guys connecting to each other? So if I did a connection, how do I show that? Well, typically on a blow up like this, you could do our favorite thing, which was our detail lines or our regions or our detail components. So remember, if you recall from last semester, a detail component is a component that doesn't get added to the model, but it gets added to a view. So as a result of that, we'd have to figure out how do we want to connect it. In this particular instance, I'm thinking I'd like to use bolted connection, but it's not loaded in. So if I go back to Insert, Load Family, I have to go back to English Imperial, and if I go to Annotations, no, it would be Detail Items, you have something for structure. At least you're supposed to. Watch us not have it. I don't know if we do. Might be under metals. So under metals, under structural framing, I have all sorts of profiles I can add for tops and edges and whatever. So the question is, do I have anything here by way of connections between members? It's the problem with between this computer and the one in my office. Slightly different stuff. So it seems like this is just for the actual pieces of metal, not for bolts and connections of that sort. So we go back to,
Where do we download this from?
huh?
What? Where do we download?
Aren't those from the major link that I had sent you guys before?
No, I'm saying if we don't find any of the major one.
Well, that's what I'm looking for now as we talk. Of course, I just hit the wrong button. So if we go back to structural framing, we go to steel. Oops. Go to, yeah, no, I'm in the wrong one, I think. We want to go to details first. Metals. So metal fabrications would be something like a metal stair. Cold form metal is not going to be something that you put on structural steel. Cold form, despite the name, is not done in the cold. It just means that it's not hot rolled steel, which is typically the category we use for structural steel. Then it says structural metal studs framing. That's again going to be more cold form. So these are going to be things like hat channels and studs for the wall. Then it says steel decking. So this is where you get your furring patterns. Then it says steel joist framing. This is going to be for your highest level. So if I'm on a roof level and I want to do it in, say, open exposed joists, this is where you would do that. You even have like the section here. I think it's interesting to show it. Oops. Do you see how big this guy is? This is the type of thing that you'd be cutting through in like a superstore, like a Costco, where it's that open ceiling. This view is showing you as I cut through it. And then the other view would be, that's the only problem. You have to manually open all of these. So I'd have to go back to detail, load family. This would be the side. There's this guy. So if I wanted to do like a roof with an open bar joist, that's what I would look like. And you can actually change the seat, and as it connects to the wall. Now, that's just to kind of get you started, and then you can, of course, this is designed for like detail, so it's not going to show you the whole width of it. So anyway, that's just an example, but as we go through, we go back to load family, we're still trying to find these connections. So common work results for metals, metal fastenings. So now we're cooking with gas. You have gusset plates, column bases, anchor bolts. This is where you start to see the pieces that would be potentially holding things together. So here it is, the L bolted connection. It's another fancy way of saying, what's going to hold two pieces of steel together. So if I go to the L angle bolted connections, just to remember, we're in metal fastenings. So here's your flow chart. Detail items, division 5, common work results for metals, and metal fastenings. It's that easy, guys. So if I go to open, you see this guy's pretty beefy. So clearly I might not be in the right league if I'm specing the size. So something that needs that many connections is probably a little overblown for me. So here, you realize it's parametric, and it says what's the height, what's the bolt spacing. I'm able to modify these things. So number of bolts, I can make it say just 3, and it will change it and make it a little bit smaller. Then it'll say what's the diameter of my bolts, and again, these are all something that somebody somewhere has to figure out for you. So you don't want to just, in the real world, toggle with these things and it not matter. But eventually you can place them. And you'll see here, the expectation is that you'd put it together. Now, of course, for this one, you'd have to manipulate it still. The bolt spacing's 3 inches. It'd probably look something like that. So now, if I go to my 3D view, though, you won't see it. And the reason for that is because this was a detailed view. This was a detail. It wasn't an actual bolt I put in. And the question would be why? Well, if if I put it in for one part of my model, then you better be damn well sure I'm putting it in all parts of my model. So were you here at the guest lecture last week? So one of the things we talked about was like when you hand over building information modeling. This is an example of something that doesn't get modeled in every single connection because it would be mind-numbing to do that, right? But some people have this expectation because they're handed over a Revit model that if I put it on one part of my drawing, it should show up here. Well, I just got done telling you that's the reality. You have detail things and you have model things, and they're not always the same. Does that make sense? So basically, in summary of this particular nugget, we should understand how to cope things as we put them together, be able to manipulate levels, okay? Be able to pick the plane we want an object on, know how to go to our reference library and download additional beam sizes, understand that we have annotations for structure, that should be in a different folder, that would be used for just drafting lines and details. I'm not expecting you guys to know how many gusset plates you need, where the bolted connections need to go, but the expectation would be if I ask for, do a typical column connection drawing, you at least know how to put the pieces together and, you know, show me what that could look like. Yeah. Any questions about that?
Confirm, Professor, the way you went all the way to the L angle bulky connection.
Yeah.
You want to go on one more time?
I guess I could. For you? Maybe.
I just want to try it.
I understand, Nicholas. I'm just giving you a hard time. Before I forget. I'll make sure it's actually charging.
Professor,
Yo.
just to confirm, like, about the decking, so you add the decking and then go into the detailing to offset it so that it doesn't interfere with.
Well, that's not the detailing. That will actually move it in the model.
Okay.
Yeah, so when you're manipulating the levels and stuff, that's like legit.
Okay.
But I guess my point was, in this instance, I was kind of working backwards. So what would conventionally happen is that you set your floor to whatever you set the floor, right? And the reason for that is because that number is set by a bunch of other parameters. So if I am working with an MEP engineer and I need to understand how tall my ductwork is and how that aligns with my need for space in the plenum, and I need to understand, like, based on zoning, what my whole floor height is and all that kind of stuff. Typically, you're not looking to the structural engineer to be like, hey, how tall is my column? One of the benefits of both wood, actually one of the benefits of any structural system, is that it's pretty much flexible. If I'm pouring a concrete beam or post, I get to set the height of it with the formwork. If I'm taking a piece of timber or a piece of lumber, I get to cut it, right? If I'm using steel, I can get it custom made whatever length I want, right? So don't let the tail wag the dog. You're not going to be like, oh God, I got to have my whole floor shift up because the beam is this long. That's not going to happen, right? It might happen in really crazy situations where you have a really, really small run and they're like, well, in order to do that, it's a custom cut or something. So anyway, in your particular models, since you have the floor-to-floor set, you'd want your building to follow that. And that means that you're probably going to have to go back into your parameters and modify the offsets.
Okay, and that's for the decking part, just to make sure it doesn't interfere with the finish.
Correct. So in your instance where you already have floor-to-floor heights and everything done, you'd probably just want to come in and then shift out whatever floor you have to make sure it's actually legit. If you just have like a concrete floor that's 4 inches thick, the question you have to ask yourself is how is that being supported? Yeah. Even so, if it's a wood building, you still have gypcrete, which is a pourable layer. And the reason why they wouldn't have any idea why. I'm doing two of you now. They wouldn't have any idea why we'd use something like gypcrete or concrete, even in a wood building. What do you think that might be? There's a few reasons for it.
What is this material?
So gypcrete is a gypsum product which is in drywall that's mixed with concrete, so it's a little bit cheaper. Doesn't have to be structurally robust, but it just helps keep something, level and hard.
So is that maybe it holds the loads better on the floor?
Okay, so maybe it distributes the loads better on the floor. It helps with sound abatement. So if I'm building an apartment and I just have sheets of plywood, and that's all I'm having for my substrate, and I'm just going to put carpet directly on that, that's not nearly as soundproof as if I put at least a few inches of thickness. And the reason why gypcrete's used is because you don't need it to be that thick, but at least it provides something. The main reason is for this term. It's leveling. So if I have just a plywood substrata and I have nothing above it, if there's little deviations in the height or little slopes, if I pour something that's going to kind of liquidy get in to where it needs to go, it will be what's called self-leveling. And self-leveling is particularly important in commercial applications where I can't really afford to have an 1/8 of an inch differential if there's ADA issues and it's going to feel bad and certain finishes are not forgiving, blah, blah, blah. All right. So Agustin asked a very specific question. He wants to go back to the library. I believe that's what you asked for. So if I go to if I go to structure, if I go to annotate, I know why my brain's in the wrong mode. So I'm not in the right view. So if I'm in my view that I wanted to add a call out for, right? And I want to add a specific type of thing, I got to go to the detail component section. The first place in order for me to do that is I got to go to detail component. I got to load my family. So again, we're not in the real world anymore. We're in drawing world here. Because we're in drawing world, you have to remember one critical thing. You have to start off in details, right? Yes, I'm sure somewhere in this Revit model, you could find in this library an L-shaped bracket that has bolted connections to it. You probably could find that. The problem is I don't want that. I want a drawing of this to then put in this model, in this fun specific view. So I have to start off with detail items. The detail items will typically be broken out into different divisions. Structure, depending on where you're building and how you're building, is going to be in different categories. If I'm building a stick building, that would be under wood. If I'm building concrete, it would be under concrete. In this particular instance, we have it under metals. So we got done going through all the other options earlier in the lecture, and it seems like the common denominator was it's a common work for results. And common work for results then leads you to metal fastenings. So metal fastenings, again, if we explore this category once more, that could be something like a shear stud on the top of a plate. That could be a steel plate that's just on the ground. In our particular instance, we're looking for a L angle bolted connection. So you'll see here they have one that's double-sided, one that's just one-sided, one that goes long ways. Gusset plates are typically found in trusses, wood trusses. So if I was designing a wood truss, I might actually detail metal as my connection. This would be where you find it. Then we have expansion bolts, column bases, a so-called carriage bolt, which looks like this, which I'm sure you've seen in the wild before. Anchor bolts are similar. Carriage bolts are unique because they have a flat, round head on one end. These actually have two bolts on both sides. An anchor bolt that hooks is very common in residential construction. Does that answer your question?
It did 100%.
Yeah, I was going for 110%. I was trying to answer your question and much, much more. So, I was contemplating belaboring the topic and having you understand that you could do this in every material. if I'm in 3D and I go over to this guy over here, these are our structural concrete walls. Now, I'm not going to go ahead and, most people are not going to build their buildings out of concrete or lumber. So I'm not really interested in having you learn specifically about all of that. But suffice it to say, if I go to the structure tab and I go to wall, I could build structural walls. The structural walls are most commonly going to be found in foundation systems, or, you know, specific types of buildings might have, say, a concrete structural wall. But typically, a wall that's structural would be concrete or a footing of some kind. So, you know, if I were to draw this in the wild, it would look something like this. More common, though, than just drawing structural walls in this day and age, it's just going to be structural columns. And structural columns, again, can come in different shapes and sizes. So if I'm not doing it out of metal, I might have a column that is going to be out of concrete. So you'll see here, I go to my column section, and I only have these wide flange beam profiles. So if I go to load family, my first question would be, if I go back to my structural columns, how do I load in different materials? Well, good news for us, this is one of the more intuitive places on our file. You'll actually find that we have both precast concrete and concrete. Did everyone here take materials, means, and methods yet?
I think yes.
Yeah? You did? Well, do you remember?
I mean, I don't remember like the class number or whatever.
Well, this is where you talked about everything that goes in a building. Metals, concretes, soil dynamics briefly. I don't teach it here, I teach it at FCC. But when I say the difference between precast and concrete, the difference is precast means it's built in a factory, put on the flatbed and shipped to a site. Concrete is everything else, which is typically done cast in place or CIP. Okay? So CIP or cast in place is going to use formwork on the site. Typically, your column structures in a building could be this exact type. So you have round, you have square, you have ones that even include the drop caps. So if I'm building an apartment, this is a very common thing to see. Then you have rectangular, and then a rectangular with a drop cap. So for the sake of being fun and showing you what Revit's capable of, I'll do one with the drop cap. So let's just say I'm building a building, and I'm going to make a new grid. And I'm going to go to level 1. Let's go frame. Okay. So you'll see here on this particular view, we have a filter on anything that's framing related, and that's where these things show up. Now, you could have a view in which you don't see framing. Okay? So let's go ahead and let's debug that. If I go to level 1, and I think I should be seeing something that I don't, the first thing I taught you last semester you should always do is go to visibility and graphics. And first things first, columns are there untoggled, but if I do S and I go to structural columns, it says location lines aren't there. I'll apply it, and it still doesn't show up. So then my question is, maybe I'm just not on the right level. So if I go to 3D view, you'll see this is pretty low. So it's getting cropped off on my view, so I don't see it. So any ideas on how I could try to adjust that and see it?
Well, it's definitely not showing how, because you mentioned it's on the right level. It's not.
Was you go to the elevations and yeah, just input that.
So you can see it there. And what's happening is it's below level 1. So I go to properties, and I'll say the top of it should be at the roof. Boop. Now I see it as a column on level 1, and on the roof, I don't see it, but on roof framing, I see it. Now, why don't I see it on roof? Well, my theory is roof is just going to be for my shingles and stuff in this mode, and you don't want to seal the structure, because the whole point of the roof plan is not to seal the columns beneath it, right? It's to see the roof. But hypothetically, if I wanted to, I go to Properties, Visibility Graphics, go to Structure, and you'll see Structural Columns is off. So I could toggle it on if I so desired, and I still don't see it. So that's interesting. So this really should show up. But in any event, we do have it on the framing view. So if I were to kind of create a building with this type of framing in mind, you still have to kind of consider what is our typical framing spacing. Now, the thing about concrete buildings are that concrete buildings are a lot heavier, and you can get away with fewer in certain dimensions, but you still should probably be aiming for about 20 feet on center before you really break the bank. So in this instance, I can just apply 2. I can do something like this and type in the value. I get my center line. And I'll do the same thing the other way. Of course, you saw that I was probably off by a skosh. So double check, I could do this. Now I'd have to scooch those up 6 inches. So I'm sorry to just have a very basic grid again. And I want to get these 20 feet, so I can just go ahead and copy back to where this was. And I should at least have a very, very rudimentary column grid. So I go back to 3D. You'll see that this is what these look like. Little mushrooms. What's that? Okay. Whatever you say, buddy. It's fine. Everyone sees different things. I won't fault you for it. So I want to be in the one that's obscured. I'm going to go ahead and scooch this a little bit out of the way. Okay. So what you're seeing here is the column, of course, has rebar in it. It has to go up to a capital at the top that then ties into the structure. And those pieces of structure are what's going to support the building. So in the roof framing plan, now I'd have to add a floor. So if I go to the floor here, the structure would be different than the other floor we talked about. Why? Because I'm pouring everything in the field at the same time. So this would actually just be a straight concrete slab, probably 4 inches. You'll see here, this is the span direction. So again, if you take materials, means, and methods, they talk about certain concrete structures being a one-way span or a two-way span. This has to do with how the rebar is configured. So in this particular instance, because our column spaces are pretty much uniform in both the X and Y, this would be what we call a two-way span concrete structure. We don't have to go into the nuances now, but just know that if it was more rectilinear in its spacing, that would be a one-way slab. This is a two-way slab. So if I go to my 3D view now, this is not uncommon. This is pretty much how you'd imagine a building, say in DC or whatever, being built. So if you're in a concrete parking lot or something, this might be what you see when you look up. You're creating a rebar situation that's going to be reinforced. You actually get some pretty spindly looking columns, but all that work is happening in this capital to make sure that load is getting distributed down to the base. Okay? So this is just showing you how quickly, with Revit, you can do two very different ways of building a building. I want you to not have to learn how to do every little thing because your building is pretty much going to either be one of these two. So if you wanted to opt it to be concrete because aesthetically that's what you like, the thing about concrete is you can leave it exposed a lot of the time. Some people like that. With structural steel, I was talking a lot last week about how you can only build so tall, and most of the time we have to cover it up with fire protectant. Otherwise, it's going to be potentially dangerous. Any questions about this one?
What would you say, you have a client come up to you, they want the most cost-effective way of building?
It would not be concrete.
It would not be concrete, it would be steel?
Yeah. I mean, the first one would be wood. Yeah, because wood has to do with the labor. Every piece of steel has to be, think about it. I have to have an engineer really think about it. So then it's the design that's more complicated. Then I have to have a fabrication plant make it. That fabrication plant also has to do shop drawings that have to be done by another engineer. Then that plant only has to take that and bring it on site. And then another company has to erect it. That requires rigs and cranes and all these other things. If I'm building out of wood, I just build one level at a time. I just keep going up. With steel, I have to have this whole complicated rigmarole. And that's not even talking about the cost of the actual material, which steel is more expensive. Concrete, similarly, has to be formed. A lot of the work, just like in painting, is all in the prep. The hardest part about cast in place concrete is I have to make all these form work, and then I have to pour into those. Does that make sense? It's a good question. So how do we feel we did on the homework? Everyone got their structural stuff done? How do we feel about the facades of our building, the front? Everyone thinks that they know everything they need to know about the outside? Yeah? Okay. Let's switch gears for a minute. So I was trying to remember if we talked about this last semester or not. So let's go back to basics since we've been rotting our brain with structure for a while. If I want to start off a project and I want to make a wall, I go to architectural wall and I can go to properties and I have all these options to pick different walls, right? We talked about how we can do foundation walls, exterior walls that are brick on metal stud, blah, blah, blah. And then there's interior walls. Have we talked at all about stacked walls? Does that ring a bell? I don't think it does. I don't think we talked about it. So let me just show you very quickly what this is all about. If I take an exterior brick on CMU wall, draw it across the way, go to fine level of detail, you'll see here there's a bunch of different materials. Let's shade it for ease. My brick is on the front, there's an airspace, then I have some sort of substrate, and then the CMU, and then the drywall on the inside. Okay? Overall, this wall assembly is going to be pretty juicy. I was going to say 19 and a half inches, okay? So that's pretty big. It's just shy of 2 full feet. Now, if I look at this wall in 3D, drywall on the back, brick on the front. There's one thing that's very noticeable, right? It's exactly what we said it was. I gave it a prescription and section, and it made the entire wall that. Meaning that if I go up, it's still brick. If I go to the side, it's still brick. It doesn't matter. It's just brick. Brick, 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 brick the whole way. So the question I have for you is, how do I make it remotely interesting? How can I do something that's on the first level that's maybe different than the second? Well, there's actually a solution to this, and it's called a stacked wall. If I go all the way to the bottom, you'll see preloaded into this job, there's something that says brick over CMU with metal stud. Now, if I were to draw this wall adjacent to the other one, and we zoom in, you'll see it's similar but different. I have brick near the front, but then I have another material there. So the question is, what is happening? If I go to the 3D view now, voila, I see that now I have this base on my wall. If I go to properties and I say, hey, I want my unconnected height to be 30 feet, the base stays the same. The base doesn't move. Well, that's a great question, Carlos. The answer is yes. But first and foremost, I didn't hear the wows and the oohs and the ahs. That's what I wanted. Thank you. So, if I were to add a door to something like this, it would just put a door in. If I put a door in something like this, it knows to crop it back, and I'm going to have to figure out how that frame detail is going to work and everything, right? This is very common in commercial building and even residential building to have what's called a water table, which is the outside equivalent of a wainscot. Okay? The water table does a few things. It adds a little bit of rigidity to the visual of the building. Like, it looks like it's anchored to the ground. It allows you to have sort of visual interests. It allows you to maybe detail things in a different way. So you can hide, like, say, a hose bib in a little more elegant of a way, so on and so forth. So back to the point. This is a normal basic wall. This is a stacked wall. You should know the difference. And your building could benefit from having a few stacked walls. So what is happening in Revit when I call it a stacked wall? Well, in Revit, what they're, because it's kind of dumb, what they're saying is, I have wall type A, and if I mix that with wall type B, and I'm putting them in some ratio on top of one another, you could call that a stacked wall. This is basic. This is basic. And I push those together, and I get a so-called stacked wall. Now, I'm sorry that I'm berating the point, but this is a quintessential element to understand, because if I manipulate one type of wall, let's say I'm in my model, and I'm like, oh, cool, I'm going to make a stacked wall. But then you go later in the game making B a different type of system. You make it a little bit wider. You maybe change the color. You will also be changing your stack wall, because all Revit's doing is it's just putting them together and then putting some detailing on it, right? Does that make sense? So if you're going to have a stacked wall, be careful on what you're doing with A's and B's if those are the two that you're putting together. So it will make more sense as we do some practice. So now that we have this, is everyone able to build one stack wall? Does everyone have this on their screen? Or are you just watching me passively? Well, stop that. Let's get to business. Please. Let's do this together. So refresher, go to wall, architectural wall, and see what's available for stacked. Is yours called exterior brick over CMU with metal stud too?
Yeah.
So if I turn the corner, it knows to kind of do something like that. It's pretty nifty.
What's different between the stacked one and the regular?
I'll get into that. So let's go to the one that's normal, and I go to edit type. So on edit type, you'll see here, it's got the classic interface. I can go to edit, and when I go to edit, it's got this very basic looking screen, but it's very important. Basically, what this does is it tells you all the stuff that's going to go inside the wall. And it's very, very poorly designed, but you can see here at the top it says exterior, on the bottom it says interior. So you're starting from the outside and building your way in. So you start with brick, then you go to the air layer, rigid insulation, some damp proofing, then you go to the masonry units. You'll see here it says core boundary. This is typically going to be used for what's doing the most weight lifting. So you could have a stud, you could have CMU block, it could be a bunch of things. Then you have the metal furring on the inside, and then of course the chip that's going to be supported. So that's typically what it would look like. And if you wanted to manipulate it, you could go to insert and insert however many layers you want. And these are all 0, and it's going to say, oh, you didn't do anything with those, so I'm just going to delete them. Okay? So I just hit cancel. Okay, easy enough. Now, if I click on this guy, and I go to edit type, all of a sudden, it's very different looking. It just says structure, edit. So that's typically your first sign. Oh, I'm in a stacked wall. When I go to edit type, you'll know. So this one, it has a thing that says stacked wall. Here it says it's the one type in the model for a stacked type of wall. If I go to structure, now we see a kind of different look. Now here's a cool little hack. On the bottom it says preview. It shows you the section cut. Okay? So you got to get a sense, you can zoom into it and toggle what's happening. So whether it's my CMU block wall on the bottom or it's my brick wall, you'll see that everything else is sort of the same. This is a key thing to understand, is that if you're going to build a stacked wall, most of the time what's behind the scenes should be the same. And we have to talk about this at length for a minute because it's really important to understand. Most modern building these days has a rain screen system. Okay? So basically what's happening in this building is if I have a water table, a CMU, and I want brick on top of that, aesthetically, pretty much all the stuff that's happening behind the wall should be painfully boring and predictable. I should have a drywall layer. I should have framing. I should have my structural wall. I should have a thermal, I'll move in a second, thermal barrier, and I should have my air gap. So why am I harping on that? Well, let's say I'm an intern or a low-level person who doesn't know what I'm doing, and I built this to go fully in the cavity, and I have no air gap here. Is that a possible way to detail it? The answer is yes, there is. I could make it a detail where I make my CMU bottom completely watertight, I seal it or do something, and I flash from the top, and all the water that gets into my cavity has a weep hole before it gets to the CMU. Most commonly, though, the reason why we use CMU is because I can provide a weep in the bottom, and that's going to allow my water to wick out. So it's not that you couldn't do it that way. It's just, this is easier. You already have the gap. You already have the framing. If you don't know, CMU and brick, when it gets wet, does retain moisture. So you don't want the CMU to have direct contact with your studs because that could telegraph in moisture. Very common problem in really bad residential houses that are older, where they're starting to have failures. Okay, after that quick lesson, you'll see here we have exterior wall, brick on metal stud. That's the guy on the top. Then you have CMU on metal stud. That's the guy on the bottom. And you'll see it says height. For the one, it's variable. That makes sense. Let's exit out of this for a second. It's variable because if I were to make this taller or larger, or smaller or shorter, I have a variable amount of brick at any given time. What's not variable is my base. In fact, that's partially why I have a base, is so it kind of keeps it level, right? Typically, bases are useful on buildings like schools and stuff because as I might have pop-ups and whatever, it kind of grounds the entirety of the building. So again, back to this, if I go to edit. Now let's say I'm like, you know what? I want my base to be super tall. It's going to be like a library. So I want it to feel like the building is for giants. You'll notice that this is a common technique in architecture where you can design the water table to be taller, and by virtue of that, it gives it a more monumental look. Now, in this particular building, it's just a wall, so it doesn't look very good. But where it looks successful is somewhere like McKeldin Library. And I'm sure a bunch of buildings at UMES. So this is the wainscot on this one. It's taller than people would be. See? And the doors themselves. Well, it's really just about the scale. We call it monumentality, okay? And it's very common in federal design, which is, of course, nodding to the Greek way of doing things. So these older temples. So again, if I go back to, something that's going to be a little bit different, I could also make this very short, and I could say I want this to be 2 feet. Okay. Now you'll see it deleted the wall that used to be here. That's because my wainscot was so tall. They said, well, I have to delete this, otherwise it doesn't make sense, right? So you gotta be careful. If I'm gonna make it 8 feet, you gotta make sure my wall is actually tall enough to receive that. Now that I modified that, the whole thing can go up again. Okay, so the versatility of this is pretty much boundless. If I understand that I can add yet another wall type, I might be able on the top to have sort of a ribbon that's a different color or a coping or something like that. So you'll see here, if I zoom in, it's creating a different value there. So if I go to a different wall type here, I could say, oh, for the top of my building, I might want it to be generic masonry. And then you're going to have to figure out if you want that to be offset. So if I want that to be offset, watch what happens to the section. It moves it out or moves it in. It moves wherever you want it. So why is this important? Well, in architecture, you might have corbelling. So now all of a sudden, your building starts to have what's called a coping or a cornice. And you can start to build a wall that is going to be the way through. This is pretty ugly because I'm just using CMU block. But if I were to go back and click the type, go back to edit, and I'm like, I don't want it to just be masonry. I want it to be brick. And I'm going to go ahead and just have it be offset a skosh more. Oh, whoops, I'm modifying the height. I meant to be modifying the... And you'll see it kind of creates like a shadow effect, right? This is very common in brick buildings, particularly ones that are older in the United States. Oh, we have all this brick. What are we going to do to make it look interesting? Well, even the McKeldin Library, I'm sure, actually this is a bad example because it's a more high federal, which is more basic. But if you're looking at, more common brick details, this is an extreme modern example where I can undulate things, I can put things in gaps. I'm sure have you all heard of row locks before? Row locks are when I kind of curve down a piece of brick. Very common they look ugly because they usually retain a lot of moisture. But little details like this, where you pop out the brick for 5 seconds, is a very common thing to do. Now, did we touch on sweeps and reveals last semester? I don't think so.
No.
What?
No.
So another thing we can do is add sweeps.
Yeah, most definitely not.
Most definitely not.
Yeah, because I remember we never really touched the wall side besides just touching the wall.
So if you go here, you could go ahead and make this a cornice, and that cornice looks like that. It's very basic, but you have it. Or I can do a trim piece that just goes on. Typically, buildings, whether residential or brick, will occasionally have a cornice line. And what's cool about that is I can set that to whatever height I'd want. I can have it wrap a corner if I want. This is found under wall, sweep. And that's how you get that guy to work. But that's when you add. What if I want to subtract? So if I go to reveal, it's the opposite effect. I can actually notch out a portion of my brick. It looks like that. So in this instance, you can actually go to edit type and you can duplicate and you can call it like reveal big, reveal small, and you can modify. So this one says default profile, but you can do all sorts of profiles. You kind of play around with it. You see here, it's a very minor detail, but if I wanted to make it a little bit deeper, I go back to the default, which looks like that. So my point being is that with stacked walls and trims and reveals and cornices, you should be able to kind of take what might be relatively basic on your building and kind of start to flash it up. You should be able to add a base to your building. You should be able to add some sweeps. And this is where, I'm not, as an architect, I'm not going to sit here and tell you, your building would look better with a sweep. So if you don't think it does, well, you don't have to do it. But your conference room, this is also something you can do on the interior. I'm going to tell you how to design your conference room. So if I have interior walls, the first thing to do in your conference room is if you want to do this, you put an elevation tag in and you have the wall in front of you. So similarly, I could take a sweep and I could add effectively a wainscot. So again, if I shade it, here's my wall. I can pick whatever height I'd like. But you can also, again, go back to our properties, go to edit type, and you'll see here, I can pick materials. If I duplicate it, just to make sure I don't screw something up, I'm able to pick a profile. So here, you'll see on sweeps, I can do a brick soldier course. Does anyone know what a soldier course means? Soldier course is when I take a brick, and instead of it being horizontal, like a soldier, it stands at attention. It stands on its end. Like this. It's common to do it over a header.
I was thinking like a wall completely built like that. I was just thinking
No, there are people who do that. This is very common.
Yeah, I can see that being like on the top or like around the windows, but I feel like it would just be ugly just seeing straight lines going up and down.
Yep. Yeah, typically you can get a lot of visual interest out of brick if you know how to do it. People mean, the cool thing about brick is that it's relatively versatile. And I think even self-criticism, at the wrong times, you're not looking at the right things. I mean, with all the patterns you could do on pavers and stuff, you can do the same thing. Here, this is a detail that I always like, where you have sort of a soldier course that's sort of splayed out, kind of goes at an angle at the end, and then they have a little interim piece there. Again, it just adds a little bit of visual interest,
It does.
You don't like it?
I do like it, but I feel like that'd be really like an additional cost.
Of course it would be, but not that much more. I mean, the brick itself is already expensive. So here's my criticism as an architect, is that now everything's done with smoke and mirrors. The brick isn't actually holding up my building. Okay? This is like face brick, and it's all being held by structure. There's probably a glulam beam here doing a lot of the heavy load lifting because it's such a wide opening, and there's just normal standard lumber on the edges. But visually speaking, if I took the same horizontal brick and went this way, visually my eye would look at that and go, it's just floating. Because there's nothing that's supporting that. This is actually kind of a cool trick, because in theory, because these are splayed in, it kind of creates an arch effect where you can imagine it's keystoned in, right? So it's a relatively inexpensive flourish that, kind of looks somewhat convincing. I'm a sucker for arches myself, but those are expensive. Is everything okay?
Yeah.
You want to talk about it?
What?
I don't know. You got all weird all of a sudden. You get the smirk on your face.
No, I was just looking at my building.
Mm-hmm. So go ahead and add those arches. Like, I mean, to me, this just looks like flimsy.
Which goes to beg, well,
Begs the
still
question.
ends up at the question. You still wouldn't design your own home? I remember we spoke on that question.
Oh, I would. I would eventually. So this is actually showing you the challenge of using brick, though, because you have to really think about how you're going to do these openings, because you have to make sure you're doing what's on coursing. You don't want to cut brick like that. And what people don't realize is that then you have to figure out this stuff, and this is what Revit isn't going to do for you. I mean, you can kind of get lulled into a false sense of, oh, cool, it's all figured out. But the reality is you have to set those dimensions up, because you don't want to have this happen on the edge. You'd rather it be like a full brick or a full block. So back to our interior example, I'm able to have a cornice at the top. Disappeared on me. So right now, the material just kind of blends in. But if I were to pick a material, now it says it's acoustical ceiling tile. This is kind of crazy. There's something else I want to talk to you about. I'm trying to remember. Path of travel. We do that another day. Oh yes, the checklist. So now that we're gotten pretty far into the Revit world with each other, I wanted to talk about AIA and the American Institute of Architects and what they consider like the best practices for kind of going about a project and adding levels of detail. It's nothing you have to memorize or anything, but I thought it was kind of a nifty, quick look. You know, a building, as you can tell, gets pretty complicated. And so one of the things you have to do is understand how am I going to go about solving these problems and do the right level of detail at the right time. So typically what you want to do is you want to define as you go through the beginning of the job, what are your phases of the project and what are you trying to accomplish in each project scheme. So typically what you're looking to do is get an idea of pricing slowly as you go. And so you want to get enough detail at the beginning to make sure you're about where the budget needs to be. And as you continue to develop information, the budget's still in line. So what they recommend you do is that you conduct bi-weekly meetings, if not weekly meetings, that you're getting consultant agreements drafted, you understand how the contractor is going to be hired, and that you're monitoring, obviously, how much people are billing. But again, there's things like program, like at the beginning, does the owner know exactly what they want in their building? Do you need to help them define that? Understanding what their acoustical requirements are, what they're trying to do for their MEP engineering, understanding if they have sustainable goals, knowing how the site is going to relate to your building is very important. But then as we go through our Revit model, this is the one that really I wanted to show you, because these are the types of things that eventually have to be on your plans. Are the plans graphically complete? Is the exterior envelope going to be properly dimensioned? Are you showing the proper dimensions on the inside as well? Are they labeled and numbered? Because if I have a number of offices, you can't just say, oh, the third office from the left. You want to give it a number. Are the partition types actually put in? That's just a fancy way of saying the walls. Are your doors tagged? Do you have reflected ceiling plans? Are you going to show the structure and coordinate that? Are the elevations graphically complete? So on and so forth. I don't have to read every single one of you. But you'll start to see it says wall sections are blown up to a certain scale, foundation details are complete, and elevator and stair specs. So the idea here is that you go all the way through and you coordinate these things with your team. And ostensibly, if you check off all of these, you will have gotten to a place where your model is complete enough for a contractor to price it and you can get a permit. And so when people go like, well, what's an architect really doing? In theory, if you're paying your firm really well, you should be able to say they did all of this. You confirm all of that. And by virtue of that, your engineers and all of that are also going to do it. So every good firm has these at least getting dust on them in an office, so God forbid they get a huge project and they forgot how to do. Like smaller jobs, you kind of just do these things intuitively, but on a job size with a team, you have to remember that type of stuff.
Is what you get paid for?
I don't get paid.
Well, architects.
Architects?
Architects.
Yes.
The meat of the bone right here.
Yeah, a little bit. We also try to make it look good, but sometimes that doesn't matter. Sometimes the client just wants it done, even if it's ugly. I mean, my first boss, as much as I obviously don't work for him anymore, the one that I really had as a mentor, made it very clear, just because the job doesn't make it into a magazine, doesn't mean that you're not doing quality work, right? That somebody somewhere has a need, and you're fulfilling that need. Not everyone can be designing the Taj Mahal, right? You have to remember that the person who has no money to put any frou-frou extras in just as well needs a place to work, needs a place to live. And in fact, it's actually more challenging to do those jobs. Because if someone comes to me and says, I want the best of the best, here's a blank check, figure it out, there's not really a limitation, and I get to just do whatever I want. A lot of times the challenges are from where you give me enough constraints and I have to figure out a way to do it. Right now I have a restaurant job where they're pretty much learning that they don't have a lot of money. to do what they want to do. And I have to arbitrate between the contractor, the landlord, and the tenant what's reasonable. Because to me, I kind of am siding with my tenant now that the contractor, I don't think they're taking them out for a ride. I think they probably could cut out 50, 60 grand from their budget and be below where they wanted to pay. And now they're acting like they're way over budget and they barely have anything they want in the project. And, you know, that's a very difficult place to be because I'm not the one building it. So then what do you do? Am I to convince my client that they should look somewhere else, get another price? The landlord's obviously incentivized for them to sign the dotted line right away. The tenant's obviously incentivized to get what they want as quickly as they can for as cheap as they can. And I'm incentivized for the building to be as nice as possible, even if that delays the job. So we all have different, very much different incentives. So ask me how I feel about this problem in 2 months, and if the building had even, you know, we got anywhere closer. But, you know, ultimately people learn very fast that things cost money. And I know it's not a great lesson, but, you know, it used to be where if an office were, if someone was building an office, I'd say it's $100 a square foot, right? For a fresh office fit out.
When was this?
This was back in like 2015. Now it's like 150, right? So if a client is doing what they think is not a lot, what's not a lot to them is 150 times, you know, 4,000 square feet. Well, how much is that? You can do the math. So, I mean, it's not nothing, even though it looks like it is. So what do you think your homework's going to be based on our lesson today?
Redoing our exterior walls.
Bingo. I don't feel like the exterior's got a lot of love.
No, you're right.
Okay, so I'm gonna walk around and see what your structures look like and what your facades look like, and after I do that, I'll post the homework and you guys are technically free to leave. But let me look at all your projects first.
You don't want to do facades right now?
You're doing your trim. Boom. Can you do me a favor really quick? You go to architecture, you go to wall, and then go to sweep, and then click on this guy. There's vertical ones too. That would be interesting. Let me show the class that before we go. Okay, anyway. Show me your structure.
Structure.
Yeah, you've been following along on the facade. So you got everything framed out?
So everything is framed out on the building. The only thing is my building. I don't think my building is ready. So I'm probably gonna have to move around some of the rooms. Probably have to figure out how to do that.
Show me the plans and what you're worried.
So some of the beams are gonna be, for example, let me show you one that pisses me off. These small, there we go. The bathrooms here.
Yeah, that's not gonna work.
They
That's
are,
not gonna work either.
they're in very,
Yeah, you can't have an elevator with the beam. Why don't you just move that whole column line into the wall?
this one
Why
here,
don't you just move that this way?
all the way here.
Yeah.
But I was keeping the 30 feet on center. But you're correct. Just move it that way and that's it.
It's as simple as that. Boopity boopity boop.
That solves the issue, huh? Just move it outside.
Lickety split.
And then here, just put a wall.
I wouldn't move that one. Just you can deal with it.
So the office is gonna have to be.
Or maybe you shift the whole offices over. Maybe that wall. Maybe you gotta change the design.
Very nice, very nice.
What's probably more likely to happen in real life is that this guy shifts up and this guy shifts up. So you, and then that way, it's already against the wall there. You're just rocking a little bit to the wall. That happens all the time.
Do they need to be at the same distance? So 30, 30, 30, 30? Or, because right now if I move this, it's gonna break away from that 30. So is it the same thing here? I can
No, you can, yeah, it's easy, it's better that you're taking it away from the 30 of homework versus adding it. But yeah, you can manipulate it a little bit.
Very nice.
I mean, what doesn't work is where this doesn't work.
Where? This one right here? Oh, no, yeah, for sure. This will have to be changed. 100%. Yes.
Nice. What is that? A cage?
This is the outdoor.
No, cool.
The outdoor system. See, the right, I would know the right you go. Doesn't go through it. I don't. Very cool. Showing out.
Anything else? No, it's good. Vertical reveals. Remind me to show you guys that vertical trend.
Carlos. I'll just begin right here. So, right here.
Let's just begin at the beginning.
So I copied this to the, I know. So I made it into this and then I highlighted everything. Hit it and then unhit just my structural view. So
Cool.
View. Is that I went through here. And this is how I had to like figure out how to do this. I didn't know that I could just like, cause.
Yeah, you can select and you say high category.
Yeah. But I
You
didn't.
should have asked me. I have email. I do check my email as much as I can, people.
And yeah, so if you go over here, I still sort of need to do the 3D model, I guess. Just for this one specifically, but it should be on all 3 floors. If you want to dissect.
How do your column layouts look?